reading club. I'm fine with either.
I'm fine with being either in a group or a club. Either way, I think.
There you go.
This is always the interesting thing with live sessions, that there's always this moment in the beginning where, just like with like a rock band, there's this audio equipment setup moment. Well, yeah, but then the lead guitarist does come on stage, so the entire crowd goes like, "Oh my god, it's a lead guitarist!" And then he's just playing a C chord.
Yeah, not me. So
What?
there you go.
Yeah, but I actually own like several guitars, so I can't deny it. That's
Oh wait, I think I knew that. Yeah, don't you know, like 8 or 10 or something?
my mom made me sell a couple of them, but there was this one point where I did own about 7. That's true.
Okay.
But you gotta have a 6 string and you gotta have a 12 string. That's that's the way it works when you
That
when
yeah,
you're a teenager. You want to feel like a
you
rock
do.
star. You just buy 7 guitars. Um, anyway, I think the audio is better now.
Hmm. Mm-hmm.
Yeah, I think the saying is you can put lipstick on a pig, but it's still a pig, like something along those lines, right? Yeah. The video is not audible, or the
Oh, voice.
oh.
Okay. Well, oh, while we're doing this, a similar idiom in Qatar, because I studied abroad in Qatar for a bit, is taking what's called an Arab shower, which is when you don't take a shower, but you just like put on some perfume or cologne and call it done.
Hey,
Um,
the Dutch also have something like that.
yeah.
It's yeah, but
So you're not like fixing the underlying issue. You're just like, putting on some perfume.
yeah, something. I think the Dutch have something called it a Belgian shower, but that's just because the Dutch love to have jokes about.
Okay, at this point you should only be able to hear me. I am just letting the audience know that I am working on it. Wait, Ankit says it's audible now. Like now? Mady and Vincent, say something. Okay. No one's saying anything, which is making me a little bit nervous.
Back or is our audio back? We can hear you now. Okay. I think that message just came in. So
I'll take that.
yeah, me too. Hmm.
What? Okay. And now the bass player starts playing a C chord.
Hmm. Hmm. Hmm.
Sure thing. So abstract. Word embeddings are widely used in NLP for a vast range of tasks. It was shown that word embeddings derived from text corpora reflected gender bias in society. This phenomenon is pervasive and consistent across different word embedding models, causing serious concern. Several recent works tackle this problem and propose methods for significantly reducing this gender bias in word embeddings, demonstrating convincing results. However, we argue that this removal is superficial. While the bias is indeed substantially reduced according to the provided bias definition, the actual effect is mostly hiding the bias, not removing it. The
Hmm.
gender bias information is still reflected in the distances between gender neutralized words in the debiased embeddings and can be recovered from them. We present a series of experiments to support this claim for two debiasing methods. We conclude that existing bias removal techniques are insufficient and should not be trusted for providing gender neutral modeling. Sure. So the idea
Yeah.
with the word embedding is that if you look at text and how it's being used, you might argue that the word dog is probably used in a similar way as the word cat. Probably because you can feed a dog, you can feed a cat. They're both animals, and you can pet them. So the way that the word is used in relationship with other words is probably similar. And there exist these techniques to then associate that numerically. So you can say, well, points that are close together numerically also have similar meaning. And there's like 1,000 techniques on how to precisely do that. I think there's a lot of variance in how you could go about that. But the idea basically is that words can be mapped to like high dimensional points in space, and that supposedly points that are related should be close together. Uh,
Yeah.
but it's really hard to pinpoint what pattern has been learned, because we're typically learning word embeddings
Mhm.
from not a dictionary but like how people are actually speaking, like Wikipedia, and those
Yeah.
are common sources, I think.
And they can be learned based on like co-occurrence. So
Yes.
yeah.
But the essence of it is like we're gonna learn them from how people use the language, and if they're used. I think co-occurrence is typically if it's in the same document or the same sentence, or then you get this big co-occurrence matrix. You do some dimensionality reduction techniques on it. Again, I think there's like thousands of variants, if not more. Yeah, like the one thing I suppose that is fair to mention is you do get these weird results. So, for example, love and hate, they are exact opposites of each other. So you could expect that they should not be similar. Then again, they are both feelings, so you could also argue that they are similar. And like, what is the right word embedding? That's sort of an ongoing research topic, precisely because there's a lot of exceptions, because love, hate, etc.
And these are learned rather than
dictated. Yeah.
They're not rule based. Mady, do you want to kick us off?
Yeah, we can do that. Okay, so word embeddings have become an important component in many NLP models and are widely used for a vast range of downstream tasks. However, these word representations have been proven to reflect social biases, example, race and gender, that can naturally occur in the data used to train them. Nice. And I like how they cited it too, so you just know who wrote it. Kaliskan et al. 2017 and Garg et al. 2018. In this paper, we focus on.
I was just going to say, I think Garg was probably the paper that got like a lot of attention and really kicked this off as a major research area. Not the Kaliskan paper didn't get a lot of discussion, but Garg really.
Right. Okay. So in this paper, we focus on gender bias, so not race, just gender. Gender bias was demonstrated to be consistent and pervasive across different word embeddings. Okay, that's good to know. Bullock-Bassi et al. Show that using word embeddings for simple analogies surfaces many gender stereotypes. For example, the word embedding they use, word-to-vec embedding trained on the Google News dataset, answer the analogy, man is to computer programmer as woman is to X, with X being homemaker. Oh, that sucks. Kaliskan et al. Further demonstrate association between female-male names and groups of words stereotypically assigned to females, males. Example, arts versus science. In addition, they demonstrate that word embeddings reflect actual gender gaps in reality by sharing the correlation between the gender association of occupation words and labor force participation data. So assuming that the gender association is pretty bad compared to the actual participation data. There's a gap there, that's I think what they're saying.
Yeah.
Yeah, and they're also showing the association between the female male names and groups of words stereotypically assigned to females, males.
Yeah.
Okay.
Vabhav, I'm sorry if I'm saying that incorrectly, says, what do they mean by pervasive? Where precisely was this?
If you can go back. Yeah, so gender bias.
Consistent and pervasive.
Yeah.
So meaning that it shows up in all of them and that it's
is there a difference?
Also hard to remove.
Is there? That's what pervasive. Like, is there a difference between pervasive and consistent?
There's like a little bit of a connotation difference.
Yeah, consistent doesn't mean necessarily everywhere. It just means that it's probably occurring on a frequent or consistent basis, I would say, is the connotation. Maybe pervasive meaning it's in all of the data that they looked at. And maybe, I'm sure we're going to be looking at some experiments soon, so it's probably demonstrated in each of those as well.
The main point here is gender bias. It's a thing. It's hard to find word embeddings that don't have it.
Yeah, that's a good way to put it. Yeah.
Important because word embeddings are used in pretty much all NLP applications at this time. Well, I should say all, but a vast majority of them. So if you have, for example, a hiring recommendation system, and part of it is looking through, let's say, resumes and like assigning them a suitability score, you might end up assigning a different suitability score to people based on their name and the traditional gender sort of role associated with that name, which would be illegal. Not good.
Right.
I use that as an example because Amazon did something similar and came up with pretty much those results, so that men were much more likely to be recommended for roles than women in general.
I guess
And
one
what was interesting.
Yeah, no, Mady, go ahead.
Oh no, I was just gonna say, I think what was interesting with that is that they didn't just look at explicitly female names or anything like that. Even words like math and engineering and like JavaScript, for example, had a strong male bias compared to having a female bias, even though they're gender neutral words.
I think there was even something about being member of a sports.
Men's lacrosse team.
Yeah,
was the
that was
addictive
which funny thing about lacrosse, they don't play that in Europe. So every time that someone mentions that one lacrosse example, the second question I always get, what is lacrosse?
It is a game that was originally Native American.
When I played in high school, I thought it was a super fun game, but it's hard to explain here. One final thing I suppose that is maybe good to mention here as well is that it has also been demonstrated not just to be the case for English, but indeed many languages. So I've done some experiments with my library called What Lies, and yes, in Dutch, in German, in Spanish, it's pretty much the same phenomenon so far that I've seen as well.
Yeah, definitely. And well, we can talk about this more later on, but I think a large part of that is also the specific data that's used to train these embeddings, because they're going to be very, very, very dependent on the corpora and the language data used to train them initially. And a lot of people use like Wikipedia, and there's a known bias where female figures in STEM are much less likely to have Wikipedia pages than male people in STEM. That's science, technology, engineering, and mathematics is what I mean by STEM. And also, a lot of people will use Reddit data, and if you're not familiar with Reddit as a social network, it is predominantly male, and also is known for having a lot of groups that engage in hateful and abusive language. So if you're using that data to train your embeddings, it's going to be to some degree reflected in your model. And I can take the next paragraph, and then we'll be back to Vincent. Recently, some work has been done to reduce the gender bias in word embeddings, both as a post-processing step, Bulukbasi, maybe, et al. 2016b, and as part of the training process, Zhao et al. 2018. Both works substantially reduce the bias with respect to the same definition. The projection on the gender direction, e.g. he to she, introduced in the former. So this is using sort of linear algebra to find, like, because it's a vector space, right? The vector that represents the word he, the vector that represents the word she, and trying to close or minimize the cosine distance between them.
So checking, oh, go ahead.
Go ahead.
Oh no, I was just gonna say, so they're checking how similar, I guess, a word is to he versus she using like cosine similarity.
I believe it's more of like
something.
It's been a while since I wrote these papers, but I believe it was more
yeah.
of a transform of the space to try and collapse along that dimension.
Yes. Well, the main technique it sounds like the technique that I'm familiar with. So the idea is you got he here, you got she here. That's a direction. King, queen.
Yeah.
Probably a similar direction. And then, unfortunately, probably also computer programmer, homemaker. That might also be the same direction. So the idea in the techniques is, how about we filter away that direction from the corpus? So you take that direction and you project, like linear algebra, project away all the data points from that one axis. Effectively, you would get like 299 dimensions of information instead of 300. But the idea here is, by filtering out that direction that contains bias, you no longer have it. But that's the theory, of course. But that's
that's the theory. So they're arguing basically, so you could do that, but it still doesn't remove bias because it's going back to that word that we talked about, pervasive. Okay.
Yeah, and I'm hoping that there's going to be a joke about you're going to make an orthogonal bit of lipstick for the pig. Like maybe we get some math jokes in there. That direction, I definitely think they're going to go to. Yeah.
And Pankaj is saying not audible, so I've I can hear it in the video, but I have adjusted the levels a little bit, so it should be a little bit louder. God, I'd love a soundboard. So by this method, they reduce the cosine distance between these two word vectors overall, and they show that the performance on word similarity tasks is not hurt. So this transformation does not reduce the utility of the word embeddings in pipelines.
You still have most of the information still in there. That's kind of the idea, yeah. My understanding as well.
Vipav says, do they take the absolute cosine distance because otherwise their definition of bias is itself biased? I think we're probably going to get into details a little bit further in the paper. It is, again, been a while since I read those. Vincent?
Yeah.
Well, like in general, whenever you're dealing with something in the realm of fairness, you always have this weird conundrum because you have multiple definitions of fairness. And I can imagine that this will be a topic that the paper goes into as well. For example, if I want to make sure that there's no negative bias for whatever wage prediction across genders, then I might still end up with a model where the accuracy for women is much lower than for men. And that might even be caused because I'm debiasing on a certain axis. Like there might be a trade-off at play. I do certainly agree that the choice that you have as a fairness metric really determines the end result. So you definitely have to be careful there.
And I will say, if you're interested in learning more about this broad topic, Cynthia Dwork has done a lot of work on this. She's at Harvard, so I would like read through her. Oh, I can actually go to her website, not the like random.
The Harvard website, yeah.
Yeah. So I would recommend going through her bibliography and looking at some of her work and the ways that she, operationalizes measures of fairness and the trade-offs, and it's a big topic.
I will also say it's a hard and unsolved topic.
Oh yeah,
there has been work done. You don't have to start from like brass tacks.
Scratch. Yeah.
Vincent, do you want to kick off this?
Yep.
We argue that.
So we argue that current debiasing methods, which lean on the above definition for gender bias and directly target it, are mostly hiding the bias than removing it. We show that even when drastically reducing the gender bias according to this definition, it is still reflected in the geometry of the representation of gender-neutral words, and a lot of bias information can be recovered. And then there's a 2, which could be a footnote to another paper, or... Oh, and there's code available. Yeah, I found it on there. Yeah, there's it's a bit of a long notebook, but they have open sourced their code, which is always a good thing. Not every paper does that.
Definitely.
Cool. Good to know.
Let's hop into the math, because we've gotten quite a few questions about that, and I think that there'll be a...
yeah, let's do that.
Do you want to take us?
Yeah, let's do that. Okay, so gender bias and word embeddings. In what follows, we refer to words and their vectors interchangeably. Okay, so the definition and existing debiasing methods. Well, Bassi et al. Define gender bias of a word W by its projection on the gender direction. So I think this is what we were talking about earlier, where the bias of the word W is the similarity of W to he minus the similarity of W to she. And that is the projection of the word W on the gender direction, is what that basically means, assuming all vectors are normalized. Okay, so the larger a word's projection is on he minus she, the more biased it is. They also quantify the bias in word embeddings using this definition and show it aligns well with social stereotypes.
So just as sort of like another way of thinking about it, if you have these sort of like, 2 vectors and you have a vector in the middle, something that is, unbiased will split the distance, and something that is more biased will go more towards one or the other vector. Do you think that's a fair way of thinking about it?
Yeah. No, that definitely makes sense. So if something has like a positive bias, it's male bias, and something has a negative bias, it's female bias. So let's take the word doctor or math. I'm assuming it's going to have a very strong male bias. So it's going to have like a positive representation. Would that be accurate,
yeah,
more or less?
And then I think one of the examples from that paper would be nurse would be more biased towards the female vector. The vector for the word she, I should say. We are using the pronouns he and she here as stand-ins for gender.
Yeah.
Which looks like it's what Vincent was going to say.
No, like the goal would sort of be maybe that if you take hopefully you can come up with some sort of filtering technique such that potentially king queen is also on this axis, you can imagine. But the trick here is that king and queen, you could argue that those are somewhat valid, maybe, because it's hard to be a queen without having a gender. So that's how language works. So the hope is to have a technique where you can keep those things intact, but definitely don't have the doctor nurse have such a correlation. That's the hope.
So you're looking at like gender neutral words and not like gendered words.
I think
like king, queen, like mother, father, etc.
It depends on the approach, I think. But I might be confusing papers, but I recall reading one paper where they have a list of biased words where they say, well, this is bad, we don't like that. But then there's a couple of biased with like gendered words, which are fine, like sister, brother, mom, dad.
Well, the assignment of gender is sort of, I don't want to say that like the existence of gender is neutral, but
well, but you can argue that mother, that has a different meaning than father because of the gender that's in there, and you cannot argue that for doctor and nurse. Like that'd be plain silly. So that I think is the main difference. But yeah.
Okay. Okay, so that's how they're defining it, which is the similarity of any word to he minus the similarity of any word to she. And it's the projection on the gender direction there.
Yeah.
Okay.
Which.
All right.
And I will say, just like a quick aside, English does not have grammatical gender. Presumably, most people watching this would know that. But in languages that do have grammatical gender, clearly this is going to be a completely different discussion.
Okay, I'll just read the tiny paragraph here before you can. Rachel, okay. Both Belklassi et al. And Jia et al. Proposed methods for debiasing word embeddings, substantially reducing the bias according to the suggested definition. Okay.
And I believe that'll be probably. Ooh. Do you want to get the?
Yeah.
Footnote here?
Another work in this spirit is that of Zhang et al., which uses an adversarial network to debias word embeddings. There, the authors rely on the same definition of gender bias that considers the projection on the gender direction. We expect similar results for this method as well. However, we did not verify that. Okay. And the gender okay. Yeah, that's not. Okay. Go ahead.
And just to respond to Vibhav in the chat, again, I am sorry if I'm saying that incorrectly. They should include both kinds of bias into consideration by taking the absolute value. Otherwise, words like nurse, which are biased towards the female gender, will decrease the bias score. So I believe unbiased would be 0 here. So the positive versus negative distinction is just to make it easier to sort of quantify the direction of the bias. But when we say reduce, we mean move in one direction, and neutral would be balance between the two, if that makes sense.
Yeah, so we want gender neutral words to be as close to 0 as possible.
Yep.
We don't want, doctor to have 1, for instance.
Yes. But good point. All right. In a seminal work, Bolifasi et al. 2016b use a post-processing debiasing method. Given a word embedding matrix, they make changes to the word vectors in order to reduce the gender bias as much as possible for all words that are not inherently gendered, e.g. mother, brother, queen. So this is what we were talking about with words where the being in that category includes gender information necessarily. They do that by zeroing the gender projection of each word on a predefined gender direction. Zeroing the gender projection, sorry, I think I said direction. In addition, they also take dozens of inherently gendered word pairs and explicitly make sure that all neutral words, those that are not predefined as inherently gendered, are equally close to each of the two words. This extensive, thoughtful, rigorous, and well-executed work surfaced the problem of bias and embeddings to the ML and NLP communities, defined the concept of debiasing word embeddings, and established the de facto metric of measuring this bias, the gender direction. It also provides a perfect solution to the problem of removing the gender direction from non-gendered words. Not about perfect. However, as we show in this work, while the gender direction is a great indicator of bias, it is only an indicator and not a complete manifestation of this bias.
So I guess the word perfect there, I think that like mathematically, I do think that you can have I can imagine there's a proof there. I think with the Gram-Schmidt process, you can sort of guarantee that you remove all correlation because it's linear algebra. So I imagine that's what they mean with perfect.
I think
Oh, could be.
qualifying it would have made sense. Like mathematically perfect would have probably
Yeah, oh yeah,
helped if that's what they mean.
theoretically perfect.
Theoretically, yeah.
And
Okay.
Just like a quick point about this.
Yeah.
I think it's a really good technique in general. I think it addresses a lot of the problems, but I think my biggest worry about is that there's two things. A is that it assumes that gender is a binary, which we know from just like usage of language in the world is not the case. And B, it really talks about only gender in only this way. So I think it's a good technique, but it is very, very limited in scope.
Yeah, religion would be more like there's multiple religions, of course. So how would you do that? I guess one thing that's also maybe fun to mention is there do exist similar techniques for like tabular data. But one thing that surprised me about this is you also have to make this assumption about how analogies work, because you are assuming that the entire embedded space is linear, right? It might be the case that the relationship between 2 points, especially if a non-linear algorithm training for this, can you really just project linearly, and is that enough? Like that to me sounds like quite an assumption, especially if you've been training using a non-linear method. I believe the original word2vec, I think that was based on counting, I think, like a count matrix, if I'm not mistaken, but it could be wrong. But I would especially like I would not mind to be critical here if it's a non-linear system that you're training. But that's like my main caveat with that technique in general.
Definitely. Also, people in the chat are saying it's not audible, so I have hopefully adjusted. Oh, it was him. Okay. Sorry, it was Osvaldo who lost the audio.
Okay, cool.
Yeah. Vincent, do you want to take the next paragraph?
Sure thing. Cao, and I'm hoping pronouncing it correctly as well, but Cao et al. Take a different approach and suggest to train debiased word embeddings from scratch. Instead of debiasing existing word vectors, they alter the laws of the glove model. Okay, so glove, I think, is the linear, so that makes sense. Pennington is something that they mentioned there, aiming to concentrate most of the gender information in the last coordinate of each vector. Okay, interesting. This way, one can later use the word representations excluding the gender coordinate. They do that by using two groups of male-female seed words and encouraging words that belong to different groups to differ only in their last coordinate. I was not aware of this technique. I will say there's something interesting about that. In addition, they encourage the representation of neutral gender words, excluding the last coordinates, to be orthogonal. Okay, so they add a constraint there. To be orthogonal projections. So it seems like they're optimizing with a constraint based on that last index of the vector there. Which again, that's a cute idea.
I think that's footnote 5. Did we skip footnote 4? Oh, sorry, yeah, that was me. I skipped footnote 4. The gender direction is chosen to be the top principal component of 10 gender pair difference vectors.
Yeah.
Okay. So they were looking at things like he, she, him, her.
Man, woman, mom, dad.
And then do like a.
It's an average of sorts, I guess you could say.
And then this footnote.
The gender direction is estimated during training by averaging the differences between female words and their male counterparts in the predefined set. I will argue that there's something similar happening there to some extent, I suppose, but I think it's a cute idea to say, hey, we're going to try to force all of the gender information to go into this one specific vector in an attempt to make it also more interpretable. So, okay.
So if you want it to be neutral, then you would just like ignore the last coordinate of that vector.
Pretty much. So like I think the other technique tries to say, well, we're going to project away. You could interpret that as removing like one index from your vector. It just won't be, it'll be a combination of all the vectors instead of one index. But yeah, like
yeah.
Again, I always like it when people try something creative, and this is something I could not have come up with. So okay, this is like I'm excited at this phase. This is fun. This work did a step forward by trying to remove bias during training rather than post-processing, which we believe is the right approach. Unfortunately, it relies on the same definition that we show is insufficient. I would agree here. Like, it's better to prevent than to fix in hindsight, right? So I think that I was not aware of this technique actually. So I'd be curious to know more about it. So that's fun to.
Oh, I think the rest of this paper is going to be all the problems with these techniques.
Oh, sure,
Yeah.
but it's always nice that people are trying out different ideas, right? And I will say, like, the main debiasing technique that I was aware of was the post-processing one. So it's nice to know that at least something else also exists.
Which the post-processing one has the benefit that you don't need to retrain your embeddings, which if it's a very large embedding set based on a large corpus could be prohibitively expensive.
That I can definitely, well, and also like you have all these pre-trained things already and all of these different algorithms, so having to redo all of them is probably going to be a bit of work. Okay, no, that was a fun one to read. Do I take the next one or move it on to Mady? Oh, let's do Mady.
Okay, let's do that. Okay, so these works implicitly define what is good gender biasing, debiasing. According to Goldberg et al., there is no gender bias if each non-explicitly gendered word in the vocabulary is in equal distance to both elements of all explicitly gendered pairs. Okay. So there's no gender bias if each non-explicitly gendered word is in equal distance to both elements of all explicitly gendered words. In other words,
so it's the same as this definition.
Yeah. That, yeah.
Well, it's a little bit different, isn't it? Because it's saying distance here, but it's not specifying what kind of distance, because there are multiple distances possible, right? I mean, you got cosine, you got dot product, you got Euclidean. So I guess what this definition says is all forms of distance. I'm guessing here, right?
Or are they just talking about the cosine?
My
it is a
guess
common
would be
one.
Cosine.
Yeah.
Well, we'll see if they talk about it more in the paper.
Okay.
Yeah.
Fair.
Yeah. So in other words, if one cannot determine the gender association of a word by looking at its projection on any gendered pair. Okay. In Zhao, the definition is similar, but restricted to projections on the gender direction. All right, makes sense. Yeah.
Do you want to do the next little
Yeah, okay. Okay, remaining bias after using debiasing methods. Both works provide very compelling results as evidence of reducing the bias without hurting the performance of the embeddings for standard tasks.
So it reduces the things that we don't want and does not change the utility of the system overall.
Yeah, doesn't negatively impact the standard tasks and stuff. Okay.
All right, I can take the next paragraph. However, both methods and the results rely on the specific bias definition. We claim that the bias is much more profound and systematic, and that simply reducing the projection of words on a gender direction is insufficient. It merely hides the bias, which is still reflected in similarities between gender-neutral words, i.e. words such as math or delicate are in principle gender-neutral, but in practice have strong stereotypical gender associations which reflect on and are reflected by neighboring words. Okay, so they're saying that I think this is stronger than the claim that they are making, but you could think of sort of like a gender in almost a grammatical sense dimension, and then another dimension that's more like stereotypes that are sort of related to gendered concepts, but would not be reflected grammatically necessarily, if that makes sense. And Vincent, do you want to take the next paragraph?
Sure. Our key observation is that almost by definition, most word pairs maintain their previous similarity, despite their change in relation to the gender direction. The implication of this is that most words that had a specific bias before are still grouped together. And apart from changes with respect to specific gendered words, the word embedding spatial geometry stays largely the same. In what follows, we provide a series of experiments that demonstrate the remaining bias in the debiased embeddings. Yeah, okay. So I think what they're getting at here, and that also makes complete sense, is that sure, you can do this projection thing, but the clusters are still going to be clustered together. They're just going to move to somewhere else. But points that were close together before, like king and queen, are still going to be close together. Just like man and woman are going to be close together. It's just the different distances will change, but relatively to all the other points, it'll probably still be clustered. I think that's what they're getting at here, right?
Yeah.
Like, I don't know, spatial geometry stays largely the same. That sounds like clustering.
Yeah. So they're saying even after the debiasing methods that the clustering pretty much stays the same.
Yeah.
Yes.
Because and they talked about neighboring words. Maybe that has something to do with it. So we'll see.
And then there's this footnote. We note that in the extended archive version, Bullock-Bazi, which I'm hoping I'm pronouncing correctly, do mention this phenomenon and refer to it as indirect bias. However, they do not quantify its extensiveness, and after debiasing, treat it mostly as a nuance and do not provide any methods to deal with it.
Mm-hmm.
I can also certainly imagine it's really hard to deal with.
Yes. Yeah, I think this paper is just pointing it out and like ways for assessing it, not necessarily like here's how to fix.
Yeah, no, that makes complete sense. But the observation I would argue here holds true. There's one thing that's on my mind though, and I just want to ask Mady because I think she knows a little bit. She's more experienced with this than I do. Like all the claims that they're making here are for like the glove, more linear vocabulary-based embeddings. But I think we can safely argue that this also holds for most Burke stuff, right?
Yeah, that's true.
It's a different way that they get to their embeddings, but like, can you come up with any reasons why it might be better or worse? Like, I'm just wondering.
Yeah, nothing. I mean, that's a good question. Nothing really comes to mind, I would think. But yeah, no, that's an interesting question.
Yeah.
I can't think of any reason why.
I haven't run across work on it, but I would be willing to bet that we'll find a lot of the same problems.
I'm sure.
Yeah. No, if someone made me pick, I would obviously bet for yep, also biased. But I would be curious to hear if there's any subtle differences. But curiosity.
Oh yeah, there is a lot of work on this, so I'm interested to check some of this stuff out.
Mm-hmm.
It'll probably be the same.
And just to think about what might be a more concrete way of discussing what they're talking about, if you think about like a net laid on top of a pool of water, and sprinkled around the net are the different words, so it's a two-dimensional representation. To remove the gender bias, you'd like pick up a corner of the net and fold it and like cut that off, right? So things that were like more towards one side or the other are now centered around it. But that doesn't change the relationship between the things that were already on the net. They've just been shifted in space. Does that make sense? I hope that's helpful. I always think like slightly more concrete representations are good.
Yeah, this is why whiteboards are amazing, right?
Yeah.
It's okay. Well, it gets interesting here as well.
Whose turn is it?
I just went, I think. So then.
Okay. All right. Cool. All right. So this is what we're looking forward to, the experimental setup. So we refer to the word embeddings of the previous works as hard debiased. That's Bullock-Bazi et al. And GN glove, gender neutral glove, by Zhao et al. For each debiased word embedding, we quantify the hidden bias with respect to the biased version. For hard debiased, we compare to the embeddings before applying the debiasing procedure. For GN glove, we compare to the embedding trained with a standard glove on the same corpus. Okay. And so we use the embeddings provided by, and then there's some code there, which is good for folks that want to take a look.
Always good when they share Git.
Yeah.
It's always good when people share GitHub repos. Like it's it's missing sometimes.
Okay. So for
paragraph as well? Oh,
yeah. Oh no, I was just gonna repeat. So for the hard debias, which is by Bullock-Bazi, they're gonna compare it to the embeddings before applying the debiasing procedure, because that one is post-processing. And for GN glove, they're gonna compare it on the same corpus, trained with standard glove. Okay.
Yeah. So I think the gender neutral glove will have one fewer dimensions, because they put all of the gender information in the last dimension and then popped it out.
Yeah, or they just set it to 0. I think I can imagine numerically you might still want to have like 300 dimensions, and putting it on the 0 is, I suppose, fair enough. But yes.
Okay. Did you want me to continue?
Yeah, go ahead. I think the experiment
Okay.
setup's going to be pretty.
Yeah, yeah. Okay, so unless otherwise specified, we follow Bullock-Bossy and use a reduced version of the vocabulary for both word embeddings. We take the most frequent 50,000 words and phrases and remove words with uppercase letters, digits, or punctuation, and words longer than 20 characters. In addition, to avoid quantifying the bias of words that are inherently gendered, example, mother, father, queen, we remove from each vocabulary the respective set of gendered words as predefined in each work. And then we can do the footnote.
Oh, sorry.
For that, yeah, no worries. And then for hard to bias, we use the first 3 lists from, there's some repo there, and for G and Glove, the 2 lists from that repo, which is cool. So this yields a vocabulary. Oh, sorry, go ahead.
Oh, no, go ahead.
Okay. So this yields a vocabulary of 26,189 words for hard deep biased and 47,698 for G and Glove.
So
Cool.
they're
All right.
removing the word sets that they were not removed in the original works, but they were used for valuation. So they are removed from this set of works.
Mm-hmm.
One thing I kind of wonder, so why is there such a difference between the vocabulary size between both of them?
I think it's just the training set of the original embeddings.
Oh, right, because they might have been based on different. Yeah, okay, they might have been based off a different corpus to start with. All right, that can be. Yeah, right. Fair enough.
And Bob says, has any paper tried an artificial data approach to solve this gender bias problem? Oh, yes, but I don't remember who it's by.
What's an artificial data approach?
Oh, so like creating a corpus where you have like more artificial examples talking about she, the engineer solved a bug or whatever it is.
Ah, right. Okay.
Mm-hmm.
So you're trying to sample more of the counterexample. All right, right.
Yes, people have done it. I know I've read this paper. This was an area I was working in quite a bit, like 2017, and I have only been sort of sporadically reading in it since. I can't remember any of the papers, but they definitely exist.
Mm-hmm.
All right. As explained in section 2, and according to the definition in previous works, we compute the bias of a word by taking its projection on the gender direction, so difference between he and she.
Mm-hmm.
In order to quantify the association between sets of words, we follow Kalaskan et al. 2017 and use their word embedding association test, WEAT, WEAT maybe.
Mm.
Consider two sets of target words, e.g. male and female professions, and 2 sets of attribute words, e.g. male and female names. A permutation test estimates the probability that a random permutation of a target word would produce equal or greater similarities to the attribute sets. All right.
Mm-hmm. So like an example would be if you had doctor and nurse, and then you had names like, just going to choose very, common European names here. I don't know, let's just say John and Jane. You would expect that they would be attributed pretty much equally, right? Is that?
I think so.
As opposed to
the
male names always being attributed to the male, so quote unquote, profession.
Like it reminds me of
the difference between the attribute words, if we just the target words, so the professions.
Yeah.
So the differences between the professions should always be smaller than the differences between the names that are gendered.
Yeah.
Yeah. Okay. That makes sense.
Right. Yeah. Okay.
No, so it reminds me of. It sounds a bit like one of those bootstrap tests that you sometimes did in college, where hey, it's yeah. So
right.
And Papan says data augmentation. So yeah, the thing I was talking about where you sort of create artificial data that inverts the existing biases. Vincent.
So the I think where this is going, because in bold letters it says male and female biased words clustered together, all in bold. No point, it's just a statement. So I feel where this is going. It says, we take the most biased words in the vocabulary according to the original bias, 500 male biased and 500 female biased. And there's a 9 there, so let's just double check that. There's a footnote. Highest on the 2 list for hard debiased are petite, mums, bra, breastfeeding, and sassy for female, and rookie, burly, hero, training camp, and journeyman for male. So the idea is that these words are probably like either on one end or the other end of the gender axis. And
training camp is kind of interesting though. Like it's such a gender neutral word, as opposed to like bra and breastfeeding, which I can kind of understand.
I'm gonna say it's more like boot camp. Like maybe the underlying data set had a lot of like war novels in it.
But you would expect the word boot camp then, right? That's I would agree. Training camp is a weird one. And journeyman, I guess, because man is in it. But anyway, lowest on the 2 lists are watchdogs, watercolors, Sioux, burqa, diets for female, and teammates, playable, grinning, knee surgery, impersonation for male.
I think
so I'm assuming
so like with a needle and thread.
So I'm assuming that these are still like in the biased list, but to give an impression that this is not on top of the list. It does seem that this is a somewhat biased data set in the sense that knee surgery is probably related to sports, I imagine.
Yeah.
Hard
Maybe,
to say without the training corpora.
Sure.
Yeah.
But
low-key pissed about teammates and playable though.
Yeah.
One being biased.
The one
training
that surprised
could be sports too.
Yeah. Yeah. Like a football training camp or something, right? I think I would,
One thing that surprised, like impersonation, that's a gendered word.
Training camp is the first.
Right.
There you go. Impersonation is a bit weird too.
Yeah, right?
It could be. I know that drag queens are sometimes referred to as female impersonators.
Oh.
But then you would have impersonator.
Or, I mean,
it depends on the corporate.
Again, it really depends on the corporate.
Yeah.
If this were a card game and you had it depends on the corpus card, you would easily win this game. That's the the short story of it. But okay, they have word lists, and I think that's useful. And what they try to demonstrate here is some thought has gone into it, and the word list might not be perfect, but it should serve as a somewhat reasonable proxy. That's the main thing they're trying to do.
And is this? I think these are the. These are not hand selected. These are from the trained model.
Good question. I imagine that since it's 500 on both, and they took word lists that are shorter, I think, before. One imagines this is indeed algorithmically done. But anyway, they're clustering them into 2 clusters using k-means. For the hard debiased embedding, the clusters align with gender with an accuracy of 92.5%, according to the original bias of each word, compared to an accuracy of 99.9% with the original biased version. So you could argue it's like the debiased is lower than the biased, right? But the suggestion here is it's only about 7.5%, so it's not super much. And then for the GN glove embedding, they get an accuracy rate of 85.6 compared to an accuracy of 100% before. So that's definitely better. And I think the GN glove one, that was the one where they had like the one they did the training thing, right?
With the extra dimension, yeah.
Yeah, that's right. So it makes a little bit of sense that performs better as well because it's not hindsight correction. So that difference, I suppose, makes sense. And these results suggest that indeed much of the bias information is still embedded in the representation after debiasing. And then they show a T-SNE visualization in Figure 1, where probably they did some dimensionality reduction technique. Yep, could you scroll down just a little bit for the one sentence? Because I'm wondering, they did T-SNE on projection of the vectors before and after debiasing from both models.
So here is, let me zoom in a little bit more.
So I'm wondering what's on the X and Y axes then?
I think that it's just a projection down of the overall cluster. I think it's probably just like a PCA or something.
Yeah. So they're still pretty distinct, the original one and the debiased one. You would expect to see them like mixed together if you were removing the bias, but you can see that the clusters are still pretty distinct and separate.
And they're definitely more integrated, but they're not completely overlapping. Because
it didn't solve the bias.
What we would expect if they had sort of like removed all the gender bias here is that these two clouds would be completely overlapping and the accuracy would be around 50%, because then it would be sort of like a random guess. And k-means is a distance-based clustering technique. So things that are closer together are going to be more likely to be assigned to the same group.
So I don't use t-SNE as much, but every time, so I typically use UMAP, and then you have very different numbers on the X and Y axes, which is why I was a little bit surprised, because -40 feels like a big number. Because I think most word embeddings, they tend to be like small numbers in the array, right? So it's like as if they're normally distributed, maybe -1, maybe +1, but it's not like you got -40 in them usually. Like I can't recall precisely. I'm just wondering if Mady, you also remember being in a notebook and looking at the numbers and going, well, these are small, but I don't know. It feels like -40, +40. It feels like large numbers, but it's more of a feeling than a fact, I guess. Yeah, it's also t-SNE, so I guess. Okay, but the main thing they seem to show is that the clusters you had before are still intact. It's just that stuff has moved, and indeed, you can split some of it, but it's harder to split some of it, but it's still easier to split most of it.
Sorry, I'm trying to see if I can find more information about the axes.
Could you scroll down again? Like, let's read that one sentence once more, then.
Yeah, sorry. I'm in another window. I think it is just like the. It's like
the overall projection.
Projection.
Figure 1 shows t-SNE. First, the t-SNE projection of the vectors before and after. Okay. So it's a t-SNE projection. So t-SNE, you get two vectors out, x and y. That's probably what we're seeing. And the color purple and the color teal are definitely separate.
Yes.
And then you see that with the GN glove as well.
Yes.
Pretty distinct and separate clusters when you would expect to see them mixed together.
I guess
the bias was kind of removed, or if that technique worked.
There is one other side effect, but this is like, you have to be careful when you're looking at charts from clustering techniques, because you might see a pattern that's spurious. But note, you see that big purple blob on the so there's a separate one. But notice on the chart to the left, there also seems to be, if you look at the purple cloud, it's like a little cluster. There's like a little border, right? Yeah, exactly, right?
And that's still there in the debiased version.
Well, it's hard to say if it's the same, but it's curious at least to see that there seems to be an obvious purple cluster after debiasing there, right? Yeah, so it seems those might be the ones where they put the 0, actually, come to think of it.
Yeah, that could be.
That might be it.
The last coordinate?
Yeah, might be it.
Yeah.
Oh, I'm assuming they set K to 2.
Yeah.
So it wouldn't.
I don't know. Like I'm a numerical geek. Whenever I see a chart, I really care about why clusters are appearing. But I think the main point, at least, is they say, well, sure, that one metric we used to have, it's smaller and that's good, but you shouldn't care too much, because all the relative distances between all the other vectors are still kept relatively the same.
Yeah. Okay. Yeah, which I think is a desired outcome from the earlier work, and the point that they're making here is that by maintaining that relationship, you continue to have bias in the model that is not being captured with the sort of like cosine difference measure that they're using. It is after 10 now, and we are on 1, 2, 3. Oh, we only couple more pages.
Oh, that's cool.
Do we
It's a short
want
paper.
to save the rest for next week?
We could.
Yeah.
One thing I might, it depends on how much time I have, but I'm interested in playing around. Like, I would like to reproduce some of this, actually.
Yeah.
That was one of the main reasons why I was interested in reading this paper. Like, I'm interested in this word bias, and I like making charts for it. So this looks like a very interesting one to try to reproduce, at least.
Yeah.
That makes sense.
Yeah, if you
Like at least a little bit next week.
can do it by next Tuesday, we can talk about it then.
uh,
Thursday, not Tuesday. Sorry.
I was about to say, like, bye weekend.
No,
nah.
don't work on the weekend.
Yeah, no, we'll see. I will say one thing. I suppose that I am interested in sort of touching base on with you. But like, how much time? I don't know if we have like a lot of time, or if we have to sort of close up soon. But I think that this issue is really hard to get rid of, if I'm being honest. Like the whole point of making these word embeddings is that you end up with these clusters, and now you're effectively saying, well, but we only want to have certain clusters, and it's hard to define mathematically which ones.
Yeah, I think there's a sort of a deeper underlying problem. Well, not a problem, but just like a thing that is true about machine learning. Also, I just realized that the side of this has been cut off the entire time. Let me see if I can fix it. Sorry. I know I'm wiggling. Oh, no, I have to move it over here. There we go. Sorry, everybody. Anyway, I think there's a deeper problem with machine learning as an approach where if you are learning from data and your data has been generated by a system that has underlying biases and inequalities, it is natural and sort of unavoidable, unless it is something that you're specifically working to avoid, that those are going to be reflected in your trained model. So that's true of embeddings, that's true of big language models, that's true of computer vision, that's true of anything where instead of hand constructing rules, you are it's one of the two of deducing and inferring, and I don't remember which one it is. Inferring? It must be inference, yeah. Inferring patterns from data.
Right. I mean, I think specifically with this paper, they're essentially saying bias is more systematic than just in gender projection and just in that one particular definition. Because even if you look at neighboring words, for instance, and you look at all of the neighbors of a word like nurse versus all of the neighbors of the word like doctor, they're still pretty biased. So even if you do get rid of, with Jan Glove, the last coordinate, or with post-processing, you're just removing a way to measure this bias essentially, but not really getting rid of bias by neighbors, list of professions, and other problematic things that we see. I know, a couple of weeks ago we were talking about WordNet and how problematic that data set is, and all of the issues that's arising with using and training on WordNet. So yeah, definitely agree with you there.
I remember talking to one of our researchers, Thomas. So one of the things that we were thinking of as well is like, hey, is there such a thing as a completely unbiased data set to start with? Maybe the dictionary. That feels like that could be a relatively unbiased place compared to Wikipedia. But Thomas was quick to point out that no, dictionaries are also written by humans, not that easy.
I was going to say, like, how you define a word, it can also be very problematic and gendered.
Yeah, no, like, definitely. Yeah. But that makes this even harder.
And I will say, just as former researcher, current practitioner, that these things exist, that there is bias in these systems, that WordNet has, for example, abusive language in it, is not inherently a problem. It becomes a problem when they are uncritically incorporated into systems, and the effect of the system and the underlying biases and how that will affect the users and the people who are interacting with the system, when that isn't considered and it results in worse outcomes for some groups of people, that's the harm, that's the problem. So it's not necessarily inherently bad that king and queen are like different in these systems. It is likely to lead to harm if you associate female names with nurses and male names with doctors, if it means that, let's say, men are less likely to be considered for nursing positions, or women are less likely to be considered for doctor posts or medical school. And that
because oh, go ahead. Go ahead.
I was going to say that the systems themselves and the data sets themselves and the models themselves may have these, reflections or amplifications of larger systemic societal bias. And the problem that we face as engineers is, how can we acknowledge that this exists? Because I don't think we're going to go back to all hand-built rules. I don't think that's going to happen. And mitigate them and make sure that our systems are, fair, equitable, just, and, straight up just work good.
Yeah. I mean, there's still some utility in that data, because it's you can train robust evaluation techniques on that data, because how are you going to have a proper evaluation if you can't detect abusive language? And you need that to detect abusive language. So there's still some utility there. So I would agree.
Yeah, no, the risk is in the automation of it. That's, I think, the main thing. Like how you're going to automate the thing. Like, can you say, hey, you made a mistake, and can you sort of appeal and make demand a fix? Like, these things also definitely matter.
Yeah. Can people choose not to use your system? So I think a good example that's pretty current is that in Britain they have these things called like the A levels, which are like the owls in Harry Potter. Listen, I'm not in the British system.
Owls?
Snoots, that's what they are. It's like a big test.
I like how your reference is Harry Potter and not like A levels are kind of like, our GPA here.
Yeah.
Oh, right. So it's like the final exam in high school, like that Harry Potter novel.
And what they have done, and this might change in the future, is that they have this year, obviously, things are very different, and they have algorithmically assigned scores to students.
Oh no, I just saw that today.
And as a result, students in schools that you have to pay for and that aren't free to anyone to use have gotten disproportionate to sort of the historical pattern, have been assigned higher scores than students who are in schools you don't have to pay for, which are more representative of not just the the British class system is very different from the American class system, upper class.
So people who went to private school essentially scored higher on their A levels than people who went to public school.
So in Britain, public school is the one you pay for, which is why I'm trying to be very careful with my terminology. Okay.
Well, in I guess North American lingo,
American
the school that the free school, students did bad on their A levels, according to and that's similar to
or were assigned poor scores.
Yeah, right.
In a way that was out of their control, and they couldn't opt out of.
I remember. I remember trying to look at, so they tried to be a little bit transparent about it, but there was no documentation whatsoever that they tried fairness mitigation technique. Like, that was the main thing that bothered me when I read that.
Well, this is like also like auto. Oh, sorry. Go ahead, Vincent.
No. Like, I think the only comment I wanted to add is, like, I think this is going to be a textbook example in a few years. That's the main thing. It wouldn't surprise me. But yeah, Mady.
And I was just going to say, I think that's similar to how you had machine learning systems score SAT essays, and then the essays that used bigger words or quote unquote SAT words scored higher according to the algorithm than essays that didn't use those words. And people that could afford SAT training classes and study courses use those words. So people that could afford to take those classes, as opposed to lower income students that couldn't afford to take those classes and use those words.
And for those of you who aren't familiar, the SAT is used for college admissions in the United States. So if you get a good SAT score, you're more likely to get into more colleges, and you're more likely to get more financial aid to help pay for college.
Now, it's a different system in the Netherlands, but also here there's a little bit of, well, it's not necessarily controversy, but it's a matter of public debate. Like, people who can practice these SAT-like tests more than others get a higher score. So then the question is, okay, how representative is one of these tests? And this is also inherently a hard problem, because you do want to allow students to practice because they can develop. It'd be awful if students couldn't practice. But there's bias in the system here. So anything you train on top of this is not going to be less biased. That's the main sort of lesson here.
And will probably actually be more biased, unfortunately. There's a growing body of work that shows that if you don't do debiasing and then you train a system on top of a biased data set, it will increase the bias over time.
So any simulation that I ran, it makes it extremely likely that it's amplification, not just copying bias. Yeah. Like, there are some techniques in this space that work. I mean, you've got the whole let's constrain things, etc. But usually, especially with these deep learning models, it's hard numerically to get proper constraints in. People have tried. If people are interested in sort of deep learning with constraints, there is one interesting body of work. It's called TensorFlow Lattice. It's not meant for word embeddings, but one thing that you can guarantee there is monotonicity constraints. As in, smoking is bad for your health. Any model that at any point suggests otherwise is bad, which are meaningful constraints, right? But they do also limit the model. But this sort of thing might help against Simpson's paradox. That said, I'm really looking forward to seeing if I can reproduce some of this stuff. So I'm definitely looking forward to talking to you folks again next week.
Definitely.
Same. Sure.
I know it's getting a little late in Europe now, so let's wrap this up. We got to section 3 of the paper, Lipstick on a Pig, Debiasing Methods Cover Up Systematic Gender Biases in Word Embeddings, but do not remove them, from NAACL-HLT 2019. Yeah, it says 2019 there in the PDF name.
Cool.
All right. Thanks so much for joining, Vincent and Mady, and also everybody who is watching along. And we will be back next Thursday, same time, which is 9 a.m. Pacific.
Awesome. Thanks for having me.
Yeah, it's been fun.
Thanks for coming and chatting.